We're now going to have another demo in which we further test the list array that we're learning about right now. And we're going to exercise one of the methods that we haven't seen yet that's very useful. So I guess we'll get started by then making ourselves a new Java project. And we're going to call this distinct numbers. And to give you a flavor for the big picture here, what we're going to do is we're going to use an array list to store numbers that we're going to enter from the keyboard, but we're only going to store numbers we haven't seen yet. So if we see multiple copies of the same number occurring, we'll only store the first one in our array list and we'll ignore subsequent repetitions of it. Hence the term distinct numbers to capture that. I'm going to make a new class which we will call again distinct numbers. It's going to be the only class in our project, so it's going to have a main, but I won't, well I guess I might as well check that off so I don't need to type that part in. So there we go, we're ready to go, except we're going to have to import a couple things that we know ahead of time we're going to need, and for sure one of them is going to be the array list itself. So let's do an import of java.util.ArrayList. We're also going to want a scanner because we need to input some integers from the keyboard. So for that, let's put import java.util.scanner. Oops. And then of course I need a couple of semicolons on that line, on both of those lines, to make those syntax errors go away. And I guess now we're ready to type in some code here to make this happen. Well, the first thing we're going to do is declare an array list of integers called list. And as tempting as it would be to do something like this, array list, and then the type goes in here and I want an array of integers, I can't do that unfortunately, because if you recall, I need an object in here. Array list does not accept primitives, it only accepts objects. But you recall, of course, we have this wonderful wrapper class that makes primitives look like objects. So in fact, I want to use the wrapper class for integers. So this is an example of where an object is required. We would like to put a primitive in, we can't, so we use the wrapper class to wrap it as an object. So this is an integer cleverly disguised as an object. And I call this array list list, and I'm going to say equals new array list. And remember, I don't need to put the generic type in here because the compiler is going to infer that from what I've done earlier. So I do need the pair of parentheses though, because this is the NOR constructor and I need to indicate that. So that will declare my array of integers, of wrapped integers. And of course the name of the wrapper class is actually integer with no s, so we'll fix that while we're at it here. Alright, now I also need a scanner. So let's call that scanner input and set it equal to new scanner system.in. And now that's ready to go. And I'm going to print a prompt asking the user to input their first integer. So let's do system.out.println to produce the prompt, and the prompt is going to be enter integers. And a little message that tells how to stop. Input ends with 0. So in other words, we're going to accept integers until we enter a 0, at which time the input will stop and the program will conclude. So that will produce our prompt. We haven't actually input any integers yet. We're going to set up to be able to do that by declaring an int called value. And now I'm going to put a do loop in here So we're going to do while there's more to do. So it's a do while loop, and the while condition will be that the value that will be entered is not equal to 0. So we're going to iterate as long as value is not 0. As soon as value becomes 0, we're going to stop at that point. Now, what do we do on each iteration of this for loop? Well, we're going to start by inputting an integer from the keyboard. So value equals input, which was our scanner, dot next int. And that's going to read another integer. Before we do anything at all, we're going to check to see if it's 0. And we're also going to check to see if it's already in our list that we're building of these integers as they come in. Because remember, we only want to store one copy of each distinct value. If we get multiple copies, we're going to ignore additional extra copies. So to do that, we're going to use an if statement that says if I haven't seen this number yet. In other words, we're going to use the not operator, and if not the case, that list dot contains, remember this is a method of list that returns a boolean indicating whether or not the list does or does not contain the value that we enter at this point. And value is the incoming integer. Now be careful with this, because in reality we know that we've declared a array list of wrapped integers, and yet we're using the primitive type out here. We can do that because what's going to happen is we have this boxing and unboxing principle that you understand at this point, so you know that that's not going to be a problem here. So even though it's wrapped integers that we're actually expecting to find in the list, what the compiler will do when it sees this primitive, because value is a primitive integer, it will simply box it up as a wrapped integer and use it that way for the purposes of this method call, method invocation. So we want to make sure we haven't already seen the integer before we do anything, and we also want to make sure that the integer is not 0, because that's a signal that we're supposed to stop. So we say if not list contains value and value is not equal to 0, because if it is, we don't want to put it in the list, we simply want to terminate the program. So if both of those conditions are met, then it's safe to go and add this new value to our list, and we do that by simply saying list.add and passing the value as an argument. And that then completes what we do on every iteration of the for loop, provided the if statement passes. When we're all finished, we will want to display all of these distinct integers that we've now read in. So we'll do that by, first of all, printing a little polite message telling that that's what's going to happen. So we're going to do a system.out.println, and that print line is going to say the distinct integers are and a colon and a blank. And then what's going to happen in the next little bit is we're going to list them all. We're going to list them all by using a for loop that iterates through all of the elements in the array. We know how many of them there are, and we're going to start at index 0 and work our way to one less than the size, as would be typical for indices in arrays. So I'm going to declare an integer here called I, started off at 0, and then on every iteration, or at the end of every iteration, I'm going to check to see if it's still less than list.size, which is a method of list telling how many elements are currently in the list. And then of course between or after every iteration, I'm going to bump I up by 1, so I'll just say I++ to achieve that. So what do I want to do on each loop or each iteration? I want to print something out, so I'm going to do a system.out. And we'll do a print instead of a print line so that we get them all on a single line. And we'll print a blank delimited list of these integers. So each iteration we will print the next one. So we'll do a list.get, which gets the item at index I. And the index here will be the value I, the for loop counter. And I'm also going to print a blank. So we have blanks separating each of those integers from one another when they print. That's all we've got. and that should do the trick. There's no syntax errors, it's all ready to go. So why don't we just go ahead and run it and see what happens? Well, what exactly happens depends on what integers we input, so let's begin inputting some integers here. How about, well, let's keep life simple and enter 1, 2, 3. Let's put an extra 3 in, and then 4 and 5. And let's go back and put a couple more 3's. And then let's put another 5 in here. And let's put 9, 8, 7. Go back and put an extra 8 in, and a 6. Now that should print 1, 2, 3, 4, 5, 6, 7, 8. It won't be in that order, of course, but it should print only one copy of each of these integers. So in order, what we should see, I guess, is 1, 2, 3, 4, 5, 9, 8, 7, 6. That's what we should get. So we're going to input our 0, which is what's going to kick us out of the for loop here, and then go ahead and do the rest of the program that prints the list. So the distinct integers are 1, 2, 3, 4, 5, 9, 8, 7, 6, just as promised. How about that? It worked just fine.